Good morning, everyone, and thank you for joining us. This is the first session in our new live webinar series where we explore practical, often overlooked strategies to get more value out of your database infrastructure. I'm Tanmay. I'll be setting the stage today before handing it off to my colleague Bianchi for a technical walkthrough. In today's topic, we'll be focused on identifying your most painful queries in MySQL, the ones that are silently impacting your user experience and budget. This isn't about deep optimization theory. It's about practical ways to regain control in systems that are already under load. A bit about us. I lead the product team at ReadySet and work closely with engineering teams solving scale and performance issues in real production environments. Joining me is Bianchi, our senior solution architect who's worked with dozens of teams from startups to enterprise and helped them make sense of chaotic query loads in MySQL. He'll be walking through a live demo shortly. Now, here is what we're going to cover in the next 30 minutes. First, I'll walk through why understanding your query corpus is more urgent now than ever. Then we'll talk about what makes it challenging, where teams often misstep. Bianchi will show a hands-on method for identifying problematic queries inside MySQL. And finally, we'll open it up for Q&A. As we go, please feel free to drop your questions in the chat. Let's get started. Let's start with the why. Query performance isn't just an engineering concern. It directly affects business outcomes. Amazon once reported that every 100 millisecond delay costs them 1% in sales. A separate study found that just a 2-second delay during the transaction flow can lead to a 60% drop in conversions. And in Google's 2024 study on mobile web performance, over half of users abandoned the site if it took longer than 3 seconds to load. Now, while front-end optimization gets a lot of attention, back-end database latency is often the hidden or the silent contributor. This isn't new information, but many teams still treat performance regression as edge cases, when in fact they're systemic and recurring. Now, here is where things get more pressing. In 2023, Gartner found that 70% of IT leaders went over budget on cloud spend. And some organizations are spending up to 5% of their ARR just on data infrastructure. We are in a cost-constrained environment in 2025. That's not hidden. And teams are being asked to do more with less. So this isn't just about speeding up the app. It is about keeping infrastructure spend sustainable. Now, that's all good, right? That's all doom and gloom, but there is some good news. You don't need to optimize everything. Query workloads typically follow a Zipf distribution, which means 20% of the queries are responsible for about 80% of the workload. These broadly fall into two buckets: high-frequency short queries that overwhelm with volume, and complex long-running queries that tie up the compute. Yet, many teams still take a reactive or anecdotal approach to performance, reacting to incidents rather than proactively identifying systemic load patterns. That's what we're here to shift. Now, with that context in place, let's look at how to take action. Bianchi will now walk you through a practical method to surface and analyze high-impact queries in MySQL, with an emphasis on speed and signal, not complexity. Bianchi.
Well said, Tanmay. Can you hear me well? Well said, Tanmay. Can you hear me well?
Yes.
All right. So I have some notes before going to the technical part of this webinar. Welcome you all attending. Thank you for attending this webinar with us today. If you don't know me, I am Bianchi. I am a senior solution architect at ReadySet. And before we go, it's good to emphasize that ReadySet supports 100% of the MySQL wire protocol. If you connect your application to ReadySet or to MySQL, your application will know that there is a MySQL there, right? There is no difference. So ReadySet attaches to your environment as a as a replica, and we'll monitor binary logs for new writes, and we'll update caches. But how to detect the main topic of this webinar, how to collect the queries, check the queries on your environment. So first of all, I would like to bring performance schema. Probably you are familiar with this in MySQL. Most of the time, historically, performance schema is it's blaming for some overhead, but since 5.7, we have this performance schema enabled, and maybe you are using mostly of the default instruments already, and you don't know, right? If you don't have it enabled yet, so find time to enable that. And one of the things I would like to call the attention is that if you want to collect real queries on your environment, as Tammy said, you have high frequency queries, simple ones, but you can have as well very complex queries. And maybe these complex queries will have more than 1,024, and then you need to tune your MySQL to adjust this to a good size for get your queries in. Having said that, this is a production environment. Of course, I'm simulating here a production environment where we have queries running here. And let's see the queries we have here, right? We have some queries. We have the application user running queries on our database, right? If we go too many times, and then we can see that we are in a production environment. We must be careful, right? Uh, Having that said, how do we get the top five, let's say the top five queries affecting our production by time and by the frequency of these queries? I will bring a query here to the source and to try to, let's bring some formatting to this thing. Uh, these are the queries. We have the number of execution of these queries here, and we have the last duration of the queries. This brings us a way of thinking that can be twofold, right? We have high frequency queries, as we see here, the high execution and fast queries. And we have queries that will be a little bit more complex, but have a little bit longer time, right? So this gives us the complete query. As you can see here, we can easily export to outside file and get this query exported to, let's say, uh, a ready set instance. So as security is something for everyone, we need to check our configuration first. So to make sure we export the file to the right place, and also to don't have MySQL crying a river if we don't go, don't get this file to the right place. So the file is generated. We can easily check the contents of the file right here from the MySQL client. And what we can do is that query we run was the query to select the top five queries and get this queries outside the database in a file. So this file can be checked as we're doing here. This query here does not make sense. This is something internal check or being run by MySQL itself, but we have some other queries, the same queries we had on the screen. So what we can do right now is to, as I have a ready set connected here, as I said before, ready set will connect to your environment as a replica. So if I run show replicas here, I can see that we have a replica. And this replica is ready set. I'm going to show you in some minutes. So by now, let's do something. Let's get this file over ready set and make sure we can load this file with the queries we want to the ready set server. So the ready set is here. Let me clean up the screen. So what I'm going to do is that I'm going to check the file. I transfer that to my ready set host to uh, Baden, right? The slash temp. And then what I'm going to do right now is just to get this file uh, piped into the MySQL here. So it's asking the password. Let's run these queries. And these queries are running against ready set. At this point, we have all the queries going to the upstream database, right? And it's done. So let's see what ready set can tell us about these queries. Now we have a command here, which is the show proxy queries. We can run to check all the queries my ready set received and the proxied over to the upstream database. We can check that. And then at this point, I can see that ready set also says which of these queries are supported or not, right? SQL is a very large language, and we are always bringing more support to ready set. Let's say about the support, we have enough to support almost 80% of the whole cases we have in SQL, right? So the queries we sent to ready set now is available from this list, show proxied queries. To make it better, I can just add the word here, supported uh, queries, and then I have all the supported queries. You can see that out of my command, I have this ready set support that says yes for the queries ready set already tested, and we can cache. So at this point, what I'm going to do is that, so if we can create the cache, I can just um, make sure I can create cache from, and then I can put the whole query, or I can get the query ID uh, to create a cache for this query. So now the next command will be show caches. When I'm going to see, sorry about that, if I can spell that correctly, if I can see, I can create a ready set cached my uh, my query. So from this point on, I have ready set responding requests like this query from the ready set. That is, we don't have more this frequent, high frequent queries hitting our database anymore. It's replied from the cache right away. We can do a quick test here if we can. For example, if I get just a quick second, what I'm gonna do is that if I have the query running on my database, let me do a show process list here, and let me do a show full process list. I have the full query here, right? Let me see if I have I have support already set for this query. What I can do is that create cache from, if I can spell that correct, cache from, oops, the cache is not okay. We create a new cache from this query, and then if I come here on ready set and execute this query again, it's going to take the first execution. It's going to take a little bit because we have a cache miss inside the ready set. But after these new keys are populated inside the cache, we have this query running very, very, very fast from the cache. So I have 12 minutes. I have 3 minutes uh, to do the rest of the things here. Let me just a quick second. I will get back to MySQL here uh, to make sure I can show you how to configure the slow query so you can collect your queries, right? I'm gonna do this, and then what we're gonna do is that I'm gonna check my current configurations for the slow query. Just a quick second. Uh, it's always on. It's all on. This is the configurations I need to get in place, right? At this point, I can check how many queries I have on this file running a command from the MySQL client. Wow, I have 12 megas of queries collected on this file. So there is a command on the collection of MySQL clients, which is the MySQL dump slow. I can just run this guy, and this guy will give us some interesting statistics about the queries we have here, so we can find the problem queries here. We have queries running fewer times, but this one is no good. But this one is a great candidate for our analysis. So it's running a lot of time, and it's analyzing a lot of rows, and it's taking let's say 7-8 milliseconds. So the whole stuff, the 4,000 executions are taking kind of a uh, 3,000 seconds to run all this guy. This is something we can improve with ready set. This query is easily cached, as we saw before. This has support of ready set, and then we can just get these queries and create caches. One of the things I would like to emphasize here to close this up is that both methods, slow queries or performance schema, are available to you. So you can, when you call us or contact us for start a demo or a POC, we can use this query and check all the support and how Ready Set can improve all the queries you have. Okay, so this is all I have to show here. Maybe we would like to get Tanmay and the slides back so we can have a QA. Tanmay, with you.
Thank you, Bianchi. That was a great walkthrough. Hopefully, folks, you got a chance to see and if how easy it is to find these things, and also apply Ready Set at the same time to address some of the performance concerns. Now, if you have ever struggled to distinguish between noisy and meaningful slowdowns, or if your monitoring tools are surfacing too much and you don't have not enough at the same time, I would love to hear more. Again, please drop your questions in the chat. We'll take them live. I see one question from Frederico. Have you come across a way to automatically identify queries and cache them? Actually, as a matter of fact, that's a very interesting question. We have, and we are actively running a private beta for a new feature of Ready Set Cloud. It's called Query Pilot. The idea here is that Query Pilot will cache everything it can to make the application sort of deployment seamless. So you would deploy Query Pilot with Ready Set as part of your application. You don't need to configure anything. The Query Pilot will look at your queries, see whether it makes sense for it to cache. It will cache it, and over time you will start to build more and more corpus of cached queries without having to do them manually, as Bianchi was showing on the screen just now. So hopefully that answers your question. Please feel free to sign up for the on the link below if you have questions. Happy to take it offline. Other question we have is from Casey. I have an application that I'm trying to optimize MySQL queries for. It was developed a while ago. Oh, it's not uncommon, Casey, and I'm not in a position to make code changes. How can this help? Bianchi, do you want to take this?
Yeah, it's an interesting question. And the thing is that to adopt Ready Set at your environment, you don't need to change anything but the host. You're going to get your application towards Ready Set and make use of cache. You can use even point your application to Query Pilot and have Query Pilot creating caches for you. It's easy. I hope I replied, Casey.
Okay. Dhirender is asking, is Ready Set similar in MySQL HeatWave that uses AI to make query optimize? We are using a combination of rule-based engines and sort of our understanding of the SQL language to make that distinction. We also have something called Query Analyzer, which uses the LLM models to help you identify or look at the queries as part of the beta that you can then make a choice to apply it. We are still not confident in the LLM's ability to optimize a particularly convoluted query to fit exactly what you need. If you're starting from there, maybe it gives you an optimized query, but for an existing query, it's a little bit more tricky. We want to make sure that there is no discrepancy between the result set. So we have a beta within our as part of our beta, we have a query analyzer capabilities that can potentially help there. So hopefully then that answered your question. I have another one from Sunil. Can Ready Set be deployed in a private data center? That's a great question, and the answer is yes, absolutely. Ready Set is available in two different ways of deployment. The first one is our Ready Set Cloud, which is a fully managed service available on AWS Marketplace. And then the other one is what we call as Ready Set Private, which is something that you can deploy on that you can deploy on your private data center or any other hyperscaler for that matter. Both of them are fully supported by Ready Set, and are ready for production deployment. So hopefully that answers your question. Frederico wants to know, does Ready Set invalidates caches as data changes? That's a fantastic question. I'll let Bianchi answer that.
Yeah, Ready-set does not work with TTLs or cache invalidation or data expiration. So once you have Ready-set and create your caches, Ready-set will collect from the binary logs connecting as a replica to your upstream database, and will increment your caches with the new data. So caches are not invalidated. Caches does not get off the memory using TTLs. So once you have the cache created, the cache will just append new data coming into the database. And yeah, for example, let's mention that we have some key value databases that are used like caches, and you need to have some logic attached to your application to check if the data is in memory, if the TTL was not reached, things like that. And you miss a lot of time just kind of developing this kind of thing. And Ready-set delivers that to you. Ready-set does that to you. Okay.
Okay. I have one from Ramesh. MySQL removed the general cache, and Ready-set is different from that. Yes, it is different. It is quite different. Since I'm novice, just basic about how does it handle case-sensitive queries. Oh no, that's a good question. We actually normalize it, Ramesh. So it doesn't matter to us whether you're asking in different cases, like camel case or changing or something. Like we handle it. The Ready-set engine is, our query analyzer is smart enough to be able to differentiate and make that distinction. So it will work just like any other cached query. And if you are interested in learning more about how Ready-set is different than what used to be in MySQL, the query cache in MySQL, I encourage you to read the Noria paper, which was written by one of the co-founders of the company, and sort of that will give you an idea of how the technology is done behind the scenes. I'm going to link that here, and just in case you're interested. So check that out. All right, folks, we are we just have we're just at time here. Again, this was hopefully this was helpful, and please reach out. We have a Slack. You can book a demo. You can find both Bianchi and I on LinkedIn. Let us know if you have feedback, more questions. We plan to do more of these as we move forward, and appreciate your time today. Thank you.
Thanks, everyone.